Hey guys, we're going to continue on with our solving equations, and last time we did lesson 8.4 that dealt with combining like terms. This one is going to put together solving equations and combining like terms. So we're on 8.5, solving equations with like terms. Okay. When an equation has two or more like terms on the same side of the equation, combine like terms as the first step in solving the equation. For example, on our paper it has 7x plus 2x minus 7 equals 21 plus 8. Okay, so the first thing that you're going to do, you're going to combine like terms on both sides of the equation. Okay, so remember the railroad tracks that we drew going down. Okay, you would do that on your example. And so the first thing that you're going to do is you're going to combine the like terms on each side. In this case, we have two terms on the left side that have a variable with them. It's the same variable. And then on the right hand side, we have two terms that are just numbers by themselves, but they're the same term. So we're going to combine these two first. We have two positive numbers, so we simply add them together. Okay, and that's going to give us our 9x. And then we just bring this negative 7 down, or this minus 7 down, because we're rewriting our equation after combining the like terms. Then on this side, we have two terms here that's just simply adding. So we have 21 plus 8 is going to give us 29. On this paper, they leave the gap here after they got rid of this 2x. If we were writing it on our examples, like I'll show you in a minute, then we wouldn't leave that gap. You don't have to do that, okay? Now we simply have a two-step equation like we've been working on. So in order to isolate the variable and get the variable by itself, because we are solving the equation, we need to do the inverse operation. So we have a negative 7. The inverse of that is going to be a positive 7. So that those will cancel out to 0, and that'll leave us with 9x. Whatever we do on this side, we have to do to this side. So we have to add a 7 over here. Okay, so when we add 7 on this side, that gives us our 36. The way that I would like us to do it is to rewrite that equation and then take the next step. They've done that all in one. And that's okay, because we're going to do some examples in a second. But so that would leave us 9x equals 36. Okay, remember that when you have the 9 and the x beside each other like that, that is going to equal or mean multiplication. So in order to solve for that, you're going to divide. They did divided by 9 like this. I typically do the fraction bar representing division so that way you can visually see those cancel each other out. But either way is fine. So you're going to divide by 9. If you divide by 9 on this side, you have to divide by 9 on this side. And so that's what they're representing here. And you get a final answer of 4, because 36 divided by 9 is 4. Okay? So now we're going to actually work out some problems. Okay, I'm going to rewrite them on my sheet of paper, and then I'll show you where we're at. So I'm going to look at number 1. Number 1 is 3w minus 2w plus 4 equals 6. Okay, so this is our example here. Now remember that as you're doing this, staying organized in your writing is super important, and it's also very important to box in your answers at the end. Okay, so first thing I'm going to do is I'm going to draw my railroad tracks going down. It's going to help me stay organized, especially since we're dealing with potentially variables or combining like terms on both sides of the equation. So I'm going to look at the left side first because we read left to right, and I do have variables that I can combine. I have two like terms here because they have the w. Okay. On this side of the equation, I just have one term, so therefore there's nothing to combine. Okay. So I'm going to work with the left side first. So I have a 3w minus 2w. Pretty straightforward. That's going to leave me with w. Remember that when you have a single w like this, there's an understood 1 in front of it. Okay. And then I just bring down my plus 4 because I have to rewrite the rest of the equation. in order to help myself stay organized for more difficult problems. Okay, so now I have 1w or w plus 4 equals 6. And now I just have a single step equation. And I just have to get rid of this 4. I have a positive 4, so the inverse of that to get rid of it is going to be a negative 4. Okay, and that's going to leave me with w on this side. And whatever you do over here, because those will cancel out and equal 0, you have to do over here. So I have to put a negative 4 over here. That leaves me with 6 minus 4, or plus a negative 4. And so that's going to leave me with a final answer of w equals 2. Okay. Moving on to number 2. Number 2 reads 7x plus 3 plus x equals 16 plus 3. Okay. So here we have terms on both sides of the equation, okay, that we will need, like terms that we'll need to combine. So I'm going to draw my railroad tracks here. I personally like to work with the left side first because we read left to right. So to me that makes more sense. I also like to deal with the variable first, which happens to be on the left side also. So on this side of the equal sign, or the railroad tracks, I have 7x and x. Remember that there's an understood 1 in front of this. So we're basically saying 7 plus 1. So it's going to leave me 8x. And then we bring down our 3 because it's a different term. So we're just continuing that on in our next step of the equation. On this side, I have 2 like terms. Okay, because they are 2 numbers without a variable. Therefore, that makes them like terms. And so we have 16 plus 3, which is going to give us 19. Right? My next step, I have a 2-step equation now. I have 8x plus 3 equals 19. So the first thing to isolate the variable is going to be to get rid of this 3 on this side. I have a positive 3, so the inverse to get rid of that is going to be a negative 3. It's going to leave that at 0 and make those cancel out and leave me with my 8x on this side. Whatever you do on this side of the railroad tracks has to be done over here, so I have to put my negative 3 over here. So now I have 19 minus 3, which is going to give me 16. Now, to further isolate the variable and get it by itself, I have to do the inverse here. Remember that 8 right next to the x like this means multiplication. So the inverse of that is going to be division. So I'm going to divide by 8, which will cancel these out and leave me with my x by itself. Whatever happens over here has to happen over here. So I have 16 divided by 8, and that's going to give me a final answer of x equals 2. Remember that you can plug your answer back in to make sure that everything is correct. So if I were to take this 2 and this were to be the correct answer, that would mean that every time that I have an x up here, I can put 2 and it's going to give me the same answer on both sides. So let's just try that and see if it works. I'm going to write in pencil this time to show a difference. Maybe pencil works. There it goes. Okay. So I'm going to rewrite the equation, but this time instead of putting x in the equation, I'm going to put 2. So I originally had 7x, so that means 7 times 2 plus 3 plus originally was x, so plus 2 equals 16 plus 3. So now I'm just solving across. Okay, so I have 14 plus 3 plus 2, and we can go ahead and solve these two together since we already know the answer there, 19. Okay, so this side should add up to 19. So now I have 14 plus 3. It's going to give me 17 plus 2 equals 19. 17 plus 2 is 19, so therefore 19 equals 19. So this check is correct, so that means we have the correct answer. Okay, so on this paper, you guys have 12 problems. We've worked out the first 2 together. You should have been writing everything down as we were going so that you have an example that was worked out with you, 2 examples. And we discussed the example that's given to you on the paper as well, okay? So you're working out 3 through 12 on your own. All of the problems either have just one term on the right-hand side, or the like terms don't deal with a variable, okay? So you won't have a variable on both sides of the equation just yet, all right? If you have any questions, feel free to email me. See you later, guys.